All right, here's a quick video just to recap some of the concepts for chapter 7. So, not a lot, but a couple of the questions that you saw on the quiz and that you'll see on the test is simply, adding and subtracting, combining some of these radicals. And you just need to understand really when you can and when you can't. Okay, so to add or subtract, combining anything, they must be the same index, which is the root or the little number out inside. So the index number is the little number, and those things must be the same, and the stuff inside the radicand has to be the same as well. So if you look at this one and you see, okay, 5x, 5x, so they both have the same stuff inside, but they are not the same index number. Okay, this has an index of 2. It's a square root. We just don't write the 2 there. So I cannot do this. This would be a not possible question, like one on the quiz. You cannot combine a square root and a cube root, even if the stuff is inside. It has to have both same index, same radicand. So this one, they're both square roots of 7x. So it's like 1 square root of 7x plus another square root of 7x. So this would be then 2 square roots of 7x. So even though we can combine these, what doesn't change is this piece. It should still be the same. It's kind of like its own variable. When you combine these, or combine something like 3y plus 2y, you get 5y. The y doesn't change. Same thing here with the radical. So the next piece is, okay, kind of little situations that you see then. So I have 6 square roots of 3x plus 3 square roots of 3x. So each of these are the same. Now I'm just adding that number out in front. Okay, so if I have 6 of them and I have 3 of them, so when I put them together, I have 9 square roots of 3x. And with this one here on the right, subtraction, they are both cube roots of 7x. So again, same index number, same stuff inside, so I can simply just subtract those. So 10 minus 4 is 6 cube roots of 7x. And the last one I wanted to do was just kind of look at some of the multiplying pieces. So one of the questions that you see a lot is expanding a binomial, so 2 terms, and expanding meaning we're going to square it. But a lot of little mistakes on the quiz was that means you are multiplying it by itself. So you have to distribute one into the other. So the square root of 3 times the square root of 3. And I'm going to write everything out for this one. So that's the square root of 9. And then the square root of 3 times the square root of 5. So again, when you multiply these, we can do it. They're both square roots, but then we multiply what's inside. It becomes the square root of 15. And then the same thing here. Square root of 5 times the square root of 3, so another square root of 15, and then the square root of 5 times the square root of 5, which is the square root of 25. Now I'm just kind of showing that little step in between, because square root of 9 is 3, square root of 25 is 5. Some of you would probably just write that right away. We can put these two together. So I have 2 square roots of 15. And then I can put my 5 and 3 together. So I have 8 plus 2 square roots of 15. And then sometimes when you combine these, you get situations where you can simplify this. But this is as far as this problem would go. Okay, so there's some adding, subtracting, and combination of both multiplying and then the adding as well. Now here's an example on multiplying kind of a bigger piece. So again, we have 2 cube roots here, so I can put these together. And a lot of people on the quiz put them together right away. I'm going to simplify this kind of first. So can't really do anything. The 4 is the 4, but I can do the cube root of 27. That is 3. So a 3 comes out, and then the cube root of x to the 5th. So 3 goes into 5 twice. I'm sorry, 3 goes into 5 once. So I get 1x outside, and then I have x squared left in. So again, what I'm doing is I'm breaking this into x cubed times x squared. So the cube root of x cubed is a single x, and then this gets left inside. Now, I also can put my 4 and 3 together, so I have 12 times x times the cube root of x squared. And now on this piece, 16 is the same as 8 times 2. I'm doing this because 8 is a perfect cube. And then I can also take the cube root of x to the 6th. So I have my 2 from the start. Cube root of 8 is also 2. Cube root of this I can't do, so it's going to stay inside. Cube root of x to the 6th. 6 divided by 3 is 2, so x squared, leaving the cube root of 2, this guy that we couldn't take out. So now together, 2 times 2 is 4, x squared times the cube root of 2. Now I still have to put both of these together, so I have 12 times 4, 48, x times x squared, so that's x cubed, and then the cube root of x squared times the cube root of 2, so 2x squared. So 48 x cubed, cube root of 2x squared. Okay, so there's a multiplying and simplifying problem. And then the last piece is division. So on division, we can write these as a single radical. So I can just kind of make this one big one instead of two separate ones. So I'm going to do that right here. This is the cube root, or excuse me, square root of 20x to the 7th y to the 5th over 5x squared y. So now I simplify this. So make sure when you're looking at the test, am I just being asked to divide or am I being asked to rationalize? Those are two totally different concepts. Here I am being asked to divide this, so I just put them together and simplify. So 20 divided by 5 is 4. X to the 7th over x squared, we subtract these, so that's x to the 5th. And then y to the 5th over y, so it's a 1, so 5 minus 1 is y to the 4th. Now, simplify this further. Square root of 4 is 2. Square root of x to the 5th, I'm going to break that up so we understand that. So it's square root of x to the 4th, which is x squared. I can't do anything with that. Square root of y to the 4th is y squared. So I'm still left with this square root of x inside. So that's my final answer. So again, with the division, you write it as a single radical and then simplify everything. And simplify a little bit further based on the root. And so that will get you this far in terms of a division problem like this. So it's different than rationalizing, but that's how you divide.